Hey, I hope you're doing well. In this short video, I want to talk about continuity, specifically on what do graphs look like with different discontinuous type aspects. In order to do that, I'm going to illustrate this by drawing some pictures. So when you think of continuity, at least when I think of continuity, I think about putting my pen on a piece of paper and drawing a curve without lifting up my pen. And so that's my idea of continuity here. So when I'm looking at continuity, I'm thinking of a curve that doesn't have any breaks in it. So I'm going to consider this continuous. Now, what are some discontinuities? Well, one of the discontinuities that we normally talk about is something called a removable discontinuity. So this is a removable discontinuity. In other words, I'm basically having a hole sitting in the middle of the graph. In other words, if I go from the left side to the right side, I have to go through this emptiness. And this is what we call a removable discontinuity. In a later video, I'll talk to you why about it's called removable, and that's more of an algebraic thing rather than a graphical thing. So another type of graph that we talk about is something called left continuous, where there is a jump. So this is called a jump discontinuity. And this is actually something called left continuous. I don't know why I wrote it like this, but that's okay. Left continuous. The filled in dot, the functional value, is attached to the left side of the break. Now, in a very similar fashion, we can have another jump discontinuity, and this is called a right continuous graph. The filled in dot is sitting on the right hand side. There are a few other discontinuities that I'd like to talk about. So, one of the things you may have heard of is a vertical asymptote. So those are graphs that kind of look like this. And there is some asymptote there, and we normally label this like x equals, I'm just going to pick the number 5. So this is called an infinite discontinuity. And actually, I like to call it a double infinite. Because on the left-hand side, we go to positive infinity, and the right-hand side, we're going to negative infinity. There are lots of combinations of these. So for example, I could have a graph that's infinite on one side and right continuous on the other. I could have a graph that's infinite on both sides, but they both go to positive infinity. So there are lots of combinations of these. One of the discontinuities that I haven't talked about is called a chaotic or a wild discontinuity. And I want you to think about something that's oscillating, like the sine curve. But instead of the sine curve being stretched out, it's going to get compressed. So here's something that I called a wild, or, well, I'll just call it a wild discontinuity. I was going to call it a chaotic one. So that's a curve that comes in and then violently oscillates and never really gets to the line, but just keeps going up and down faster and faster. And this is a wild discontinuity. So I hope this small little video was helpful in discussing some of the different types of discontinuities that we're going to be talking about. Like always, have a great day. If you got any questions, let me know. Bye.